Okay, so let's talk about amortization of loans, or amortization of loans. I always have a hard time saying that word, but an amortization is like it's a payment schedule. So it's like how long it takes you to pay off a loan, right? And to answer the question, how long does it take us to pay off a loan? We're going to start off by considering an example that seems different, but you'll see why it's useful to consider if we're trying to figure out how long it takes to pay off a loan, right? And the example that we're going to consider is the example that we talked about in the previous lecture, in lecture 19, example 2. We said in that lecture that we would come back to that example, and here we are coming back to it. So the example was this, just to jog our memory, right? You want to make one large initial deposit right now for the purpose of receiving equal regular payments over an extended future period. This would be like if you won the lottery or something, right? So for instance, you want to receive $3,500 at the end of every quarter for the next 6 years, and so you wish to know the present value P that you need to invest now at 8% annual interest compounded quarterly. Excuse me. So note that the present value can be thought of as the amount deposited, which, if left untouched for MT interest periods, I had some typos here, but on your notes I've already corrected it. So MT interest periods, M is the number of times the interest is compounded per year, and T is the number of years, right? So M times T is the total number of interest periods. With an annual interest rate of R, so the present value, if you don't touch it, would accumulate. If you leave it untouched for MT interest periods at an annual interest rate R, it would accumulate the same amount as a simple ordinary annuity with rent payment R based on the same parameters. So here we have the principal plus the interest gained on the amount that you deposited over MT interest periods, right? So we talked about that in lecture, I want to say lecture 17 probably, or maybe 18. Okay, and then here we have the simple ordinary annuity payments based on the same parameters, and these two things should be equal. So we could solve for P by dividing by all of this stuff, the 1 plus R over M to the MT. When we do that, so when we divide this thing by 1 plus R over M to the MT, this divided by itself is just 1, and this divided by 1 plus R over M to the MT is going to be, if you remember how fractions and negative exponents and stuff work, then you know that that's going to be 1 plus R over M to the negative MT, which is kind of interesting. So anyway, this gives us the present value. So this formula gives us the present value. So to give you an example, let's solve for the present value P in example 2 here, right? So in order to get P, we need to know what the rent payment R is. Well, the rent payment is this $3,500 that you're going to receive every month. The difference is that you're receiving this amount instead of paying this amount. You're not paying this rent to the bank. The bank is paying it to you, I guess, right? But nonetheless, that's the rent. That's the amount that you're receiving each quarter, actually. All right, so we have that. We have the interest rate, 8% annual interest. We have the number of times it's compounded per year. It says it's compounded quarterly, so that would be 4 times, so M is 4. And we want this to happen for the next 6 years, so T is going to be 6. So I think we have all the pieces we need in order to just plug this stuff in. So we're going to say P equals R, we said was 3,500, times 1 minus 1 plus R interest rate over M, right? It's compounded quarterly, so M is 4, to the negative MT, 4 times number of years, 6, divided by R over M. So R over M. So there's that big nasty thing. Now, you might have a hard time plugging that all into your calculator at once. One thing that you could do is do this in pieces. So for example, you might do the 0.08 divided by 4 first, 0.08 divided by 4, and that's 0.2. You might also do 4 times 6, and get 24. And if I do that, then this gets a little bit easier, right? Because I can just call it 3,500 times 1 minus, well, 0.08 divided by 4 was 0.02, right? And if I add 1, that's going to be 1.02. So this is going to be 1.02. 4 times 6 is 24, so to the negative 24. Over, and then 0.08 divided by 4 again was 0.02, right? So that's a little bit nicer, right? It's a little bit easier to punch that into your calculator. So I'm going to go ahead and do that now, and I'll show you exactly like how I punch it in. Okay, so here's how this would look on my calculator. I would do 3,500 times, and then open up the big set of parentheses. And then I'm going to need to do this entire numerator, so 1 minus this thing. So I'm going to open up another set of parentheses so that I can do 1 minus 1.02 to the power of negative 24. And then I can close that set of parentheses for the numerator and then divide it by 0.02 in the denominator, and then close the big set of parentheses, right? So that's what we get, and this is the amount that we end up with, right? So $66,198.74, we'll say, right? Okay, so the amount that you'd have to deposit would be $66,198.74. Okay. So that's that one. So this is how much you'd have to deposit, at the beginning, so that every quarter for the next 6 years you could receive a rent payment of $3,500. Okay, let's do another one. Number 2, it says Rhonda has just won $147,000 in a lottery and wants to use it as a deposit to provide her with a steady monthly income for the next 7 years. Yee. With only $147,000, I don't know. I mean, she can get a steady income, but it's not going to be very high, I guess, right? But that's okay. Okay. How much would she receive each month in an appropriate annuity at 6% interest? Okay. Well, see, here we have the opposite scenario of what we had in example 1, because we know what the present value is. It's $147,000. And what we want to know is, what's the rent going to be, R, right? How much money is she going to receive? So, but we can solve for that pretty easily. We can say, okay, so let me just rewrite the formula. So we have P equals R times 1 minus 1 plus R over M to the negative MT divided by R over M. Okay. We know that the present value is $147,000. We don't know the rent payment. That's what we're trying to figure out. Do we know the interest rate R? Well, yeah, it's a 6% interest rate, so we'll say 0.06. Do we know the number of times that it's going to be compounded? Well, yeah, she wants a monthly income, right? And so she's going to receive it each month. So M is 12. Okay, to the negative 12 times how many years? It says 7 years. So for 7 years she wants this to happen. And then we're going to divide by R over M. Okay, so once again, I'm going to do a little bit of scratch work on my calculator to do, this division and this multiplication first. I'm going to get 147,000 equals R times 1 minus, well, let's see, 0.06 divided by 12. is 0.005. If I add that to 1, I'm going to get 1.005 to the power of 12 times 7, I think is 96, 84. Oh, gosh. I should have known that, right? I teach math. Anyway, 12 times 7, 84. So that's going to be raised to the negative 84th power. And then we're going to divide by 0.06 divided by 12 again is 0.005. Okay. Now, I can punch this stuff into my calculator. So, and again, I'll show you exactly how I do that. If I can get it all under the screen at the same time. So I'm going to open up a set. Well, this time I don't need to multiply by r because I don't even know what r is yet. So I just need to do this stuff. So I'm just going to open up one set of parentheses for the numerator, and I'm going to punch in 1 minus 1.005 to the negative 84. Close the parentheses around that numerator, and then I'm going to divide it by 0.005. Okay, so that comes out to like 68 point whatever. I'm going to keep as many decimal places as possible because in order to get my final answer here, notice that I'm going to have r times some number, and in order to solve for r, I'm going to have to divide by that number. So what I'm going to end up getting is, r equals 147,000 divided by whatever this number is. Well, this number is right here, okay? And I want to keep as many digits as possible, so I'm just going to leave that as is for now and say, you could write down the digits too, I suppose. You could say 147,000 equals, it was r times 68.45304 24355. Okay, so you could write all that down. But then you're going to divide by that number. So let me get a different color here. We're going to divide by 68.453042435 on both sides. 45304 24355, right, in order to solve for r. And so we're going to get, so here on my calculator, I'm just going to say 147,000 divided by that. On a lot of your calculators, you'll have like a little answer button. You can say 147,000 divided by answer, and then hit equals. If not, just punch the numbers back in, I guess. But you should get in the neighborhood of $2,147.46, we'll say. So maybe I should say R is approximately $2,147.46. So that's going to be her monthly income. Now I suppose if she's if Rhonda's still working, then this is just extra income, which is of course kind of nice, right? And maybe if she doesn't have like a mortgage or rent payment to make, then this could be good money actually. If she only has herself to feed or whatever. Anyway, moving on. Francella wants to buy a new car and is going to borrow $15,000 from a bank at 12% interest with monthly payments over a term of 2 years. Okay, so now you'll see why this is useful for us when we're trying to determine how long or like what our monthly payments are going to be for like buying a car or buying a house or whatever, right? So Francella wants to buy a new car and is going to borrow $15,000 from a bank at 12% interest with monthly payments over a term of 2 years. What will be her monthly payment and what will be the total interest paid after 2 years? Well, I have a feeling that answering that second question will be easy once we answer the first question. So let's do the first question first, right? So Francella wants to buy a new car and is going to borrow $15,000. That's the present value. And by the way, it might be useful for us to rewrite the formula P equals R times 1 minus 1 plus R over M to the negative MT divided by R over M, right? This is the formula that we're going to use. And so we know that the present value P is 15,000. What we want to figure out is the rent, right? How much is her monthly payment going to be? So we'll say 15,000 equals R times 1 minus interest rate 12% divided by number of times the interest is compounded per year. Well, these are going to be monthly payments, so the interest is going to be compounded 12 times per year, right? Once each month. Oh, I'm leading you astray. I'm sorry. It's 1 minus 1 plus that number, okay, raised to the power of negative m times t. How many years? 2 years. Okay, divided by r over m. Some of this I can do in my head. Like I know that 0.12 divided by 12 is just going to be 0.1, right? If you couldn't do that in your head, I mean, you could use your calculator still. We'll say 15,000 equals r times 1 minus 0.12 divided by 12 is 0.1. 1 plus 0.1 is going to be 1.1. 12 times 2 is 24. So this is going to be to the negative 24th power. Divided by 0.12 divided by 12 is 0.1. Okay, and so again, I'm going to punch this into my calculator to see what I get. So open up a set of parentheses for that numerator. You're going to do 1 minus 1.1 to the power of negative 24. Close the parentheses around that numerator and then divide by 0.1. Okay, so that's 8.9847 blah, 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 blah. Okay, and then if I want to finish solving for r, I would divide by 8.98474402005. 4744 2005. Okay, whatever. So on my calculator, I'm going to say 15,000 divided by that number, which comes out to about $1,669, and well, the 49 has nowhere to go. I mean, that's a 6, right? So it's got to go up to 50 cents, right? Let's say 1669.50. Hold on a second. Hold on a second. No. Okay, so here I was bragging about how I could do 0.12 divided by 12 in my head, and I thought it was 0.1. But it's 0.01, isn't it? It's 0.01. That didn't seem right to me. Getting like, that's a large car payment, right? So I was like, no, that can't be right. And this is why. It's because this should be 0.01. So let me redo this. Let me redo this. Okay, so forget that. I'm going to come back up here, change these to 1.01, change that to 0.01. I should have gotten 21.24. Okay, I'm so sorry. 21.2433872576. Okay, so this should actually be 21.2433872576, which means these numbers would also be, I'm not going to write them out, but they would also be 21.24, well, maybe I will, 21.24387256 and 21.2433872576. Okay, so then R is going to be 15,000 divided by that number. That should be a little better. So there we go. That's more appropriate for a car payment, right? So $706.10, right? Approximately, we'll say it's approximately that. Okay. So that's going to be her monthly payment. Now the next question is, what will be the total interest paid after 2 years? Okay, well, so to figure that out, here's how we're going to figure that out, right? So this is how much she pays each month. So you can figure out how much she's going to pay after 2 years, right? You would multiply this by 12 for 1 year, and then multiply that by 2 for 2 years, right? So 706.10 times 12 times 2 will give you the total amount of money she pays. Now, she only borrowed $15,000 to begin with. So if she ends up paying like $17,000 something cents, then that means the interest was like $2,000, right? So you would do whatever the total amount she pays minus the amount that she borrowed. That's the amount of interest that she paid. Okay, so what's the total interest that she paid after 2 years? Well, let's see. So total amount paid would have to be $706.10 times 12 months times 2 years. So let's punch that into our calculator. 706.10 times 12 times 2 is $16,946.40. Okay. But how much does she borrow? She borrowed $15,000, right? So the total interest, paid would be the total amount that she paid, $16,946.40, minus the amount that she borrowed, $15,000. So $16,946.40 minus $15,000 is $1,946.40. Okay, so that's the total interest that she paid. So this is her monthly payment, and this is the amount of interest that she pays after 2 years, right? Okay. So something that I kind of want to point out, because this can kind of get a little bit confusing. We talked about examples that seemed kind of like this example in the past, but they weren't quite the same. The example that I'm thinking of is in Lecture 19. We talked about Mr. Koluski, and he wanted to set aside money in a sinking fund in order to buy a $35,000 yacht in 10 years, right? And so the question is, what's the difference between what we just did and what we did for Mr. Koluski back in Lecture 19? Well, in Mr. Koluski's case, he wants $35,000, but the total amount that he pays is less than that because he's setting up a sinking fund, right? In other words, he's saving the money in advance. And so he actually ends up putting away less money than the money he ends up taking out because, he's planning for 10 years in the future, right? Whereas in Francella's case, she has the opposite situation. She's going to borrow $15,000, so she's going to receive that sum of money up front, but then eventually she's going to pay back more than that amount to the bank because she has to pay, the interest on the loan, right? So that's the difference. And so to summarize, right, if you're ever confused, like, which formula should I use, right? If you want to find the rent for an annuity, like in Mr. Koluski's case, right? So if you want to figure out how much money should I put away every month in order to save up for a certain amount, then you use this formula. If, on the other hand, you want to figure out, well, if I just borrow that and then pay it back, 1 month at a time or whatever, what's my monthly payment going to be, right? So if you want to find the rent or payment for a loan, like in Francella's case, then you use this formula, okay? So this was Lecture 19 stuff. So this was for Lecture 19. and for lecture 20. So really what it boils down to is like lecture 19 was for if you're saving money, lecture 20 is if you're paying off a loan. Okay, so saving money, paying off a loan. Okay, so now we can talk about the amortization tables, right? So an amortization is a schedule of regular payments for the purpose of repaying a loan. In Francella's case, the amortization table would look something like this, right? So her very first payment is going to be $706.10, right? Because we figured out that would be her monthly payment. In fact, every payment she makes is going to be $706.10. And since she's making monthly payments for 2 years, in total she's going to have 24 payments, right? So this table is going to have 24 rows. Now you can figure out the amount of interest that her first payment is, right? So of the $706.10 that she pays, $150 of it is in interest, okay? And then the rest of it, so $706.10 minus $150 is $556.10. That's applied to the principal amount that she borrowed, okay, which was $15,000. And so the balance, right, is going to be the $15,000, the amount that she borrowed, minus this amount of money that she's applying to the principal. And so if you do $15,000 minus $556.10, then you get $14,443.90, right? And so that's just for her first payment. For her second payment, again, she's going to pay $706.10, but notice that the amount of interest she pays is less. Why? Well, because her balance is less, right? So instead of paying an interest on $15,000, now she's only paying interest on $14,443, right? That means that more of the money that she's paying here is going to go to paying down the principal, right? And then this is her balance after the second payment. And then you can see what happens after the third one and so forth, after the 23rd one, and then after the 24th one. Notice that after the 24th payment, she still has a balance of 5 cents. So she's going to have to actually make one more payment to pay off that last little nickel of money that she owes. But the reason for that is just because of the rounding errors here. Because actually her payment amount needed to be $706.10 and like a fraction of a penny, which after the end of 2 years kind of, adds up. All right, but that's that. So in reality, what the bank would do is just have her do like $706.11 on certain months, right? So that she after 24 months she doesn't have a balance left over. But anyway, that's that. What else did I want to say about that? I think that's all I have to say about that. I'm going to give you an example, though, of how you can put this table together. So this one says, the Conrads are considering buying a new house for $143,000. They can afford a $20,000 down payment and have qualified for a 30-year mortgage at 7.75% interest with monthly payments. Determine the first 3 lines of the amortization table. Okay. So your amortization table needs to include payment number, payment amount, interest, the amount of the payment that goes towards interest, the amount of the payment that goes towards paying off the principal, and then the balance. So the first thing we should probably figure out is what the payment amount is going to be. So they're going to buy this house for $143,000, but they're going to make a $20,000 down payment. So they're not going to borrow $143,000. They're only going to borrow $123,000. So that's worth writing down, right? So amount borrowed, which, by the way, would be the present value P, is going to be $143,000 minus the $20,000 down payment, $20,000 down payment, right? So that's $123,000. That's the amount that they're going to borrow. So to figure out the payment, again, it's the formula that we're going to use is this one, right? P equals R times 1 minus 1 plus R over M to the negative MT over R over M. So we're going to say 123,000 P equals R, which we don't know, times 1 minus 1 plus the interest rate, 0.0775, divided by number of times it's compounded per year. Well, they're making monthly payments, so that's going to be 12. To the to the negative 12 times 30, because it's a 30-year mortgage, right? 30 divided by R over M. I maybe should have given us more space, so I'm going to have to kind of crunch this in. So I'm going to say 123,000 equals R times, let's see, 0.0775 divided by 12 is not very nice. I'm just going to round that off a little bit. I'm going to call it 0.00645833 maybe. When I add 1 to it, I'm going to get this. 1 minus 1.00645833 to the negative 12 times 30. 12 times 30 is 360. So to the negative 360 divided by 0.00645833. Okay. All right. So I'm going to have 123,000 equals R times, I'm ready to punch this into my calculator. Okay, so I'm going to do 1 minus, or actually I need to open up parentheses first, right? So open parentheses, 1 minus 1.00645833 to the negative 360, close the parentheses around that numerator, then divide by 0.00645833. So I'm getting 139.584 and some change. 139.584. We can divide by that amount now. And we get 123,000 divided by 139.584. And that comes out to $881.19 pretty much. Okay, so that's not our final answer, but that's going to be their monthly payment, right? That's how much they have to pay each month. So that's kind of nice to know. We can use that now to set up the amortization table, or amortization table. I always want to call it amortization, but it's amortization. Anyway, so we're going to have the payment number, the payment amount. I'm just going to call it the payment. The amount of that payment that goes toward the interest. The amount of that payment that is applied to the principal. And then the balance. And we're just supposed to do the first 3 rows of this. So I'm going to say payment number 1, 2, and 3. we now know that their payments are going to be $881.19 each month. So I can fill in that portion of the table pretty easily. Okay. Okay. Now, how much interest do they pay on that first? So for that first month, right? So so it's going to be the balance from the previous month, which in this case, since this is our first payment, the balance is $123,000. So it's going to be $123,000 times their interest rate of 0.0775, okay, divided by 12, because that's their annual interest rate, but they're making monthly payments, right? So that comes out to $794.37. Okay, so the principal, so this is the amount of their payment that's going toward paying off interest. So notice that most of their payment is just going towards paying off interest, which is horrible, right? But some of the payment does go towards the principal. The amount that goes towards the principal is going to be the payment that they made, $881.19, minus the interest, $794.37. So $86.82 goes toward the principal, which means the balance is going to be $123,000 minus $86.82. So that's $122,913.18. Okay. So then the next month we do the same thing, right? The interest is going to be the balance from the previous month. So $122,913.18 times the interest rate, 0.0775, divided by the number of times you compound that interest each year. So in this case, 12, right? So this time the interest is going to be $793.81. So the amount that goes towards the principal is the payment that they made, $881.19, minus the interest that they paid, $793.81. So this time they get to pay $87.38 toward the principal, which means the balance is going to be $122,913.18 minus $87.38. So $122,913.18 minus $87.38. So now their balance is $122,825.80. Okay, so third row of the table, and then we'll be done with this problem. Okay, so it's the interest that they pay is the balance from the previous month times the interest rate divided by 12. So that's $793.25. So the amount that goes towards the principal is $881.19 minus $793.25. So that's $87.94. So the balance at the end of that month is $122,825.80 minus $87.94. And that comes out to $122,737.86. Okay. Now, theoretically, you could continue doing this. In 30 years, 30 times 12 is 360, so they're going to have 360 payments. So you'd have to. So in total, their amortization table is going to have 360 rows in it, which you probably don't want to compute by hand, right? The good news is that you can do these kinds of things in a program like Excel or something like that that'll do a lot of these calculations for you automatically. But that's neither here nor there. I mean, the purpose of this class is to get you to understand, well, the purpose of this section anyway, is to get you to understand what this table means and how these calculations are done, right? And so this is what they do. Okay, so I have two more examples I want to show you. So suppose we want to know what the balance of a loan is after a certain number of payments, but we don't want to have to compute the entire amortization schedule in order to get there, right? So in other words, let's say you want to know, well, what's my balance going to be in 13 years, okay? But instead of doing 12 times 13 columns to get there of this amortization table, we might want to be able to just do a formula that will tell us exactly what the balance will be on that particular row of the table, right? And there is a formula for that. The formula is this, right? So the balance of a particular, that should say loan. The balance of a loan after K payments is given by this formula here. It's kind of nasty, but it's better than doing, K rows of the amortization table, right? If you want to see where this formula comes from, you're welcome to read pages 99 and 100 of the textbook, right? I'm not going to take you through the derivation of the formula, but what I do want to do is give you a couple examples of using that formula. So this one says, recall that Francella wants to buy a new car and is going to borrow $15,000 from a bank at 12% interest with monthly payments over a term of 2 years. What is the balance on her loan after 1 year? After 1.5 years? By what amount is the principal reduced between 1 and 1.5 years? What is the total interest paid during the same time interval? Okay, someone very nosy is asking a bunch of questions, right? Let's see if we can answer these questions, though. So, first of all, it's maybe helpful to remind ourselves, right, of the formula there on the previous page. So the balance after K payments is going to be the principal amount P times 1 plus R over M to the K minus the rent R times 1 minus 1 plus R over M to the negative MT over R over M. Okay, so this is the big, nasty, scary formula. Oh, no, I got that wrong. I'm sorry. This should be, so let me do it again, right? So BK is P times 1 plus R over M to the K minus R times, it should be 1 plus R over M to the K minus 1 over R over M. So I got that second part of the thing wrong, but this is the formula that we should use. Okay, so let's do it, right? We know from the work that we did with Francella that R is supposed to be $706.10, right? So that's useful, right? R is $706.10. Okay. So let's see. So what's the balance on her loan after 1 year? So after 1 year, well, she makes monthly payments, right? She's making monthly payments. So after 1 year, K is 12, right? She's made 12 payments. right? So we're going to say her balance after 12 payments is going to be the principal amount that she borrowed, $15,000, times 1 plus interest rate divided by number of compounding factors to the k, right, minus the rent payment, $706.10, times 1 plus r over m to the k minus 1 all over r over m. I don't know about you, but I don't trust myself to punch all that into my calculator at once. But here's what I can do. I know that 0.12 divided by 12 is 0.01, right? So I'm going to call this 15,000 times 0.01 plus 1 is 1.01 to the 12th, minus $706.10 times, again, 0.01 plus 1 is 1.01 to the 12th, minus 1 over 0.01, right? 0.12 divided by 12 is 0.01. That's a little nicer. And then I can do each of these pieces individually, right? So I can do in my calculator now 15,000 times 1.01 to the power of 12. Comes out to $16,902.38, we'll say. Minus $706.10, $706.10 times, open up a set of parentheses, 1.01 to the 12 minus 1, close the parentheses, divide by 0.01. Okay, so that's $8,955 and 12-ish cents, we'll say. Okay, but that comes out to, so I'm just going to say this amount minus that amount is $7,947.26. Okay, so after her first year, this is how much she has left to pay off, right? So that's kind of good to know. The next question is after 1.5 years. Well, if she's making monthly payments for 1.5 years, that's 12 months plus 6 months, so 18 months. So K is 18. So she's made 18 payments, right? So we're going to say B sub 18 is 15,000 times 1 plus 0.12 divided by 12, right? M is still 12. It's the number of times you compound in 1 year. That's still 12. But K is 18, right? So that's 18. Minus 706.10 times 1 plus 0.12 over 12 to the 18 minus 1 over 0.12 divided by 12. Okay. Now, I'm running out of space, so I'm going to just punch this all into my calculator. Actually, I have the answer right here, so I'm just going to give us the answer. You can kind of punch this into your calculator on your own and make sure that you can get this answer, but you should come up with $4,092.24. So that's the amount of money that she has left to pay off after 1.5 years. Remember, hers is a 2-year loan, so she's going to completely pay this off after 2 years, and you can kind of see that happening, right? But the next question is, by what amount is the principal reduced between 1 and 1.5 years? Well, this is the principal after 1 year, and this is the principal after 1.5 years. So we'll say principal reduced by $7,947.26 minus $4,092.24. So 7947.26 minus 4,092.24. That's $3,555.02. So that's how much she pays off between 1 year and 1.5 years, right? Hold on. 4,000. Sorry, I punched in something wrong into my calculator. There should be an 8. $3,855.02. Okay. And then the last question is, what is the total interest paid during that same time interval? Well, if this is the amount that her principal was reduced by, but that's not necessarily the total amount of money that she paid, right? So any additional money that she paid must have been to go to pay off, towards paying the interest, right? So we'll say total paid. Well, that's going to be her monthly payments, $706.10, times hold on a second. Well, times 6, right? Times 6. Because between 1 year and 1.5 years, she's going to make 6 payments. She's going to make 6 payments of $706.10. I don't know why that was so hard for me, but anyway, $706.10 times 6 is $4,236.60. So this is the amount of money that she paid, but this is how much her principal was reduced by. That means the difference must be the amount of interest that she paid. So total paid is that. So interest paid would be the total paid minus the amount that went towards the principal. And that comes out to $4,236.60 minus $3,855.02. So that's $381.58. Okay. So that's the amount of interest that she paid over that 6-month period of time. Goodness gracious, that was a lot of work. I definitely needed to give, this is like I needed a full page to do that example. But anyway, last one. Says the interest paid on your home mortgage each year can be deducted from your gross income when you compute the income tax you owe the federal government. That's good to know. So determine the interest paid in the first year and in the 10th year of the Conrad's loan from example 4. The interest paid in the first year. So I think in order to figure that out, so we'll say first year. What we need to do to figure out the interest that they paid in their first year is we need to figure out the total amount that they paid in the first year, and then figure out how much of that Okay, so here's what we can do. We can figure out what their balance is after the first year. And that'll tell us how much their principal decreased. And then we can look at the total amount that they paid. The difference between what they paid and how much their balance decreased should all have gone to interest, right? So, okay. So after the first year, we're going to say, well, what's their balance, right? It's going to be the B12, right, their balance, minus, well, no, that's not quite right, but we need to figure out the balance. Okay, so here's what we'll do. Let's figure out B12, right? B12, that's their balance after making 12 payments. That's how many payments they would have made after 1 year. So their balance after making 12 payments is, here's the formula, right? So it's going to be the principal. This is the Conrad's. So the principal is $123,000 times 1 plus interest rate 0.0775 divided by 12 to the K minus the rent, which we also figured out was $881.19 times 1 plus R over M to the K minus 1 over R over M. Okay, so that's, let's see, I'm going to do 1 plus 0.0775 divided by 12. No, divided by 12 to the power of 12 times 123,000. No. What is going on? Let me try again. 1 plus 0.0775 divided by 12 power of 12 times 123,000 is 132,878 and we'll say 50 cents. Okay, minus, for this I'm going to do 1 plus 0.0775 divided by 12 to the 12 minus 1 divided by 0.0775 divided by 12 times $881.19. So that's about $10,958.09. And then I'm going to subtract those. And that gives me $121,920.41 approximately, right? Okay, so that's their balance after, goodness gracious, that's their balance after their first year. The interest that they paid should be the difference between that, the decrease in their balance. So we'll say, so the balance was reduced by the original principal, 123,000, minus the current principal, $121,920.41. So 123,000 minus $121,920.41 is $1,079.59. Okay, so that's how much their balance was reduced, but that's not their total payments, right? They paid probably a lot more money than that. However, they paid in the first year, their rent payment, so their monthly payment was $881.19. So they paid $881.19 times 12, right? Because they made 12 payments. So 881.19 times 12. So they paid $10,574.28. That's in payments, right? So this is how much they made. This is how much they paid. This is how much went towards the principal. So the other $9,000-ish went towards interest. Therefore, the interest they paid was $10,574.28 minus $1,079.59. So 10,574.28 minus 1,079.59. That comes out to $9,494.69. Wow. So that's how much interest they paid toward their home loan. Now, if you're thinking to yourself, I'll never do this in my real life, you're absolutely correct, because the bank will do this for you. By the way, that was after the first year. We're supposed to do this for the 10th year as well, but I'm not going to, because holy schmoly, that's a lot of work. And in fact, I just made an executive decision that I'm not going to put anything like this on your test, right? In fact, probably I'm not going to put anything from this section on any tests that you have. I think this is good information, though. It's good information because even though you won't be doing it yourself, right, the bank will do all these calculations for you. It's still, I think, good for you to understand that that's what's happening, right? That's what's happening behind the scenes. So I think that's all I want to say about amortization of loans. Now you know way more than you ever thought you would about that particular concept. So we'll end it there.